Welcome. In this lecture in linear data analysis, which has multiple sessions, we'll explore the perceptron algorithm. The main concepts for this lecture are the perceptron is a simple binary artificial neuron. We'll explore false negatives and false positives because these are the way that we'll learn how to separate our training data. And the perceptron rule is a fundamental rule in machine learning. As we go through this lecture, one problem we can keep in mind is how can we learn a separation hyperplane from some given data? Well, here are the assumptions that we're going to need. The first is we'll use an augmented weight vector. So it'll be the weight vector W, and we'll augment it with the bias scalar B. And then we'll have vector-like objects, which are our data, and we'll augment them with 1 so that they match up with the augmented weight vector. The label for each data observation, it will refer to as yi, and it's either 0 or 1. Note that that is different than in many other aspects of machine learning. And the linear weighted sum we'll represent as the number u sub I, and it's the inner product of this vector-like data and the augmented weight vector. And what we'll do is we'll predict that a data vector is in class 1 if and only if this linear weighted sum is greater than or equal to 0. Let's visualize this. What we have is we have a hyperplane of separation, and let's represent that using our double-barreled H. And this is our set. We want on this side every label to be equal to 1, and we want this side every label to be equal to 0. So that's what we're trying to learn. And the question is, from our data, can we learn a separating hyperplane that causes this to happen? And the output of our artificial neuron will be either 0 or 1, and that's to match these labels. And we'll use the Heaviside step function, which is something that we defined in a previous lecture. So here's the basic algorithm that we're going to explore in this lecture. It comes from 1958 by Rosenblatt, and it was one of the earliest models I can find of an artificial neuron. Here's the key idea behind it, is to update this weight vector W. What we'll do is we'll only use the misclassified training observations. That is, we'll only use the false positives and false negatives when we're trying to learn this weight vector. And the key result is if the training observations are linearly separable, then this algorithm will converge to a result.